Ever pondered over the most efficient way to divide a network into subnets of different sizes? The answer is variable length subnet masking, or VLSM for short. This technique is analogous to a farmer optimally dividing his land into plots based on the size of the crops he plans to plant. Think of fixed-length subnet masking, or VLSM, as a method where the farmer divides his land into plots of equal size, regardless of the space each crop needs. It's a more straightforward approach, but does it sound efficient? Not quite. Some crops might need more space, others less. That's where VLSM comes in, allowing our farmer, or in our case, the network administrator, to tailor the field sizes or subnets to the needs of each crop or group of hosts. In our journey to understand the intricacies of subnetting, it's essential to introduce another player in the game, classless interdomain routing, or CIDR for short. CIDR is a method for allocating IP addresses and routing IP packets. Think of it as a refined version of VLSM, offering an even more efficient use of the available address space. CIDR allows network administrators to divide an IP address space into a hierarchy of routing domains, which can be of different sizes. This is similar to our farmer dividing his land into plots, but with an added layer of complexity. With CIDR, our farmer can subdivide his fields into smaller plots, each tailored to the needs of a specific crop. Just like VLSM, CIDR provides the flexibility to tailor the subnets to the needs of the hosts. However, CIDR goes a step further, providing even more control and efficiency in IP address allocation. It's like our farmer being able to plant multiple crops in the same field, each having just the right amount of space it needs. As powerful as CIDR is, it's a more complex technique than VLSM and should be used with care. It's like our farmer needing a more advanced knowledge of farming to manage the complexity of multiple crops in the same field. In the next scene, we'll delve into the calculation of subnets and hosts, a crucial step in implementing VLSM and CIDR. Stay tuned. In order to execute VLSM effectively, calculating the number of subnets needed and the number of hosts each subnet requires is crucial. This is where the usefulness of a subnetting table comes into play, as it helps determine the number of subnets and the subnet mask each. Imagine a farmer who needs a larger plot for a crop that requires more space. With VLSM, they can create a larger field, and if they have a crop that requires less space, they can create a smaller field. And that's the magic of VLSM. It provides the flexibility to create fields or subnets that are perfectly sized for each crop or group of hosts. Scene 3. While VLSM is a potent tool, it carries inherent complexities. Let's delve into some guidelines to help traverse these intricacies. Initially, meticulously plan your network. Comprehend the number of subnets and hosts each subnet requires before you commence subnetting. Secondly, effectively utilize a subnetting table. It proves to be a valuable tool in calculating the number of subnets and hosts each subnet demands. Next, as our fourth point, implement VLSM incrementally. Considering its intricacy, it's advisable to start subnetting specific sections of your network gradually. In the end, thoroughly test your network after deploying VLSM. This helps in ensuring a smooth run and identifies possible issues. Adhering to these steps can assure a successful and efficient VLSM implementation in your network. Remember, like our farmer, the goal is to use your resources, in this scenario, IP addresses, as efficiently as viable. You are well on your path with VLSM.